Hello, everybody. Good afternoon. Good afternoon, everybody. Welcome again to Matthew Isaiah. It's actually exciting because this is the 13th day and we're going to be rounding up tomorrow. So this feels good. Anyways, welcome to Matthew Isaiah. It's day 13. And today we're actually going to be talking about how do I do this now? The topic we're dealing with today, to me, I believe should be the first topic in mathematics. Because all those other topics, they are really not topics. I call them child's play because they are not so. Don't worry. I'm sure at the end of the class you understand what I'm talking about. So today, we're looking at differentiation. Actually, the main thing is calculus. But under calculus, we're looking at differentiation. Yeah, we're looking at differentiation. Now, from the word different, we're basically looking for difference between, let's say this thing moved from point A to point B. So differentiation is basically the difference in the change of state with respect to time. For instance, let me use the textbook to explain. It's easier for me to get examples from there. Alright. Yeah, so differentiation can actually also be called gradient. Yeah, in some way it can actually be called gradient. That's why when you begin to advance in mathematics, you see how interwoven all these things are. Yeah, there's in coordinate geometry there is differentiation, in differentiation there is coordinate geometry. Everything is aligned. In matrices there is modulus. Everything is interwoven. That's why you don't leave out a particular topic. No, you don't. Make sure you master all of it because you will still need it. One of the reasons why I said this differentiation, it should be the first topic in mathematics, is because, okay, for instance, now whenever you find the differentiation of a particular expression or variable, that's just the first difference. There's also a second difference. You can actually differentiate again. You can differentiate the differentiated and get second order derivative. That one they will teach you in maybe 100 level in the university or second year, but one of those. Well, here we're going to be talking about just differentiation. We'll talk about differentiation, talk about all of the methods of solving differentiation. There is chain rule, there is product rule, there's quotient rule, there's all of those rules basically. So differentiation is basically talking about difference in the state of a particular object with respect to time. Now, for instance, so let me give you all this. Now, if y equals x squared, for instance, find the derivative. If they say find the derivative, so if they say find the derivative, what they are saying is differentiate. If they say find dy dx, what they are saying is differentiate. Why it is dy dx is because you are differentiating this with respect to this. So it is dy dx. If what you have here is u equals t squared, then it will be what? Du dt. Because you're differentiating this with respect to this. Changing this with respect to this. Basically, that's what you're looking for. Now let's look up. So now there is the general method of solving differentiation. I don't want to go into other stressful things like first principle, all of those. If you really want, no, there's no need for that because I have actually studied past questions a lot and I know what really matters. Now, look at this. So this is the general method of solving differentiation. If you have, for instance, y equals x raised to power n, the general formula is multiply with the power subtract 1 from the power. That's it. Multiply, so that means dy dx is nx raised to power n minus 1. Multiply with the power, subtract 1 from the power. That's basically it. So this is the general method of solving differentiation. Now let's quickly look at an example. Let's look at this now. Y equals x squared. That means dy dx is what? 2x raised to power 2 minus 1, right? That's what? 2x. So when you differentiate this, you have this. The opposite of differentiation is actually integration. Because when you integrate this, you get this back. So, but we're not dealing with that today. We're dealing with differentiation and everything about differentiation. Now, look at this. You have 2x. Now imagine you were given y equals 3x raised to power 2. What do you do in this scenario? Same thing. You multiply with the power, you subtract 1 from the power. So dy dx will be what? 2 multiplied by everything, 3x, subtract 1 from this, that's 1, 3x. What do you have here? 6x. So that's basically how you solve. This is the general method of differentiating. So that means if you have something like this, y equals 4x squared minus 3x plus 6. They say find dy dx. What does that mean? The y dx is what? Multiplied by this, 2 times 4, you have what? 8x raised to power 1. The power here is 1, right? So 1 times 3, 3. This would be 1 minus 1, right? 3x raised to power 1 minus 1. That's what? 0. Now anything raised to power 0 is what? 1. So this is cancelled out already. So that's how you attend to something like this. Now this is a constant, so you just turn it to 0. It's a constant, it becomes 0, basically. Now, so this is how you solve. This is the answer to this. One last example. Y equals 5x raised to the power minus 6. How do you solve this? Dy dx equals what? So multiplied by the power minus 6. Subtract 1 from the power. Minus 6 minus 1 is what? Minus 7. So you'll be having minus 6 times 5, that's minus 30 x raised to the power minus 7. Simple as ABC. Now this is how you solve differentiation. So if we tell you differentiate this, as long as it's like this, this is how you attend to it. But now there are other aspects of it. For instance, you're having 2 variables that are multiplying each other. How exactly do you attend to that? Or you have something with crazy power. Let's attend to some of those things. So, I'm going to move to something called chain rule. Now there are many rules in solving differential calculus. Yeah, you can call it differential calculus or differentiation. Only thing you want to call it is rule. Now, chain rule. There are many rules to solving differentiation. There is chain rule. There's chain rule. There is product rule. And then there is quotient rule. Quotient rule. Yes. Now, let's deal with the first one. Chain rule. And let me show you where you use chain rule. You use chain rule where you have crazy power or impossible power. For instance, y equals 6x minus 5 all raised to the power 5. Now, if you decide, they now say find dy dx. If y is this, find dy dx. Now imagine you now decided you want to expand this thing. 6x minus 5, 6x minus 5. You now start multiplying, that's you'll have taken 15 minutes from your 1 hour that you need to attend to all of the 60 questions in your exam hall. So now, whenever you have something like this, there is in a chain and then has a power. That's why we call it chain rule. Because all of them is under this chain and has this power here. So what do? You use chain rule. Now in chain rule, let me just go straight to the point so you understand it. Now, what you do in chain rule is you equate this to a particular letter. You can say let's say u, letter u equals 6x minus 5. So because this thing is too big, let us make it u. So let u equals this. Do you understand? So once we have this, then you can now assume that means y is u raised to power 5, right? Since we've already said let this one be u, let u equals this, that automatically means y is u raised to power 5, right? Now let's differentiate this. We want to differentiate u with respect to x, we want to differentiate y with respect to u. So that means du dx is what? Differentiate this now. The power here is 1, right? From what I just thought. The power here is 1 multiplied by 6. You have 6. X has power of 1. 1 minus 1 is 0. Anything raised by 0 is 1. So x is gone. So what you have is 6. Because this is a constant, it turns to 0. Understood? Now let's differentiate this. We're differentiating y with respect to u. This will be what? Multiply by 5. 5 u raised to power. Subtract 1 from here. Raised to power 4. That's why I said this should be the first topic in mathematics, because now you begin to see some calculations, some stress in the mind. Now, this is the general formula for quotient rule. dy dx equals, let me remember it, dy du times du dx. And this is the general formula for quotient rule. That is if you make u to be this. So this is the formula. You can try to keep it in your head, but I know it offhand. So dy du times du dx. If you solve it this way, you will have your dy du. What's your dy du? This is it. So what does that mean? You write it 5u raised to power 4 times, what's your du dx? 6. Right? So what do you have? You have multiply 30 u raised to power 4. And what do you now do? You now bring back your u. Since u is this, 30 into bracket 6x minus 5 raised to power 4. This is chain rule or composite rule. Composite. I just remember that now. Composite rule. Since SS2 that they thought we did as far back as 2016. I still remember that it's called composite rule. So that's I think I would say this to maybe encourage some teachers that sometimes you don't know the child that is listening the most, honestly. Because I used to be very unserious. I used to be very unserious actually, but I think it was SS2 that was the turning point for me. Because surprisingly, I ended that term with, I came out third in the class and third in mathematics. And I was surprised because I didn't read anything. How did I come out third? I don't know. I was not like, okay, if I could do that thing without actually planning, then let's see what happens when I plan. And I give myself to studying. Then I began to start studying. I studied on quadratic. I cannot forget quadratic equation. I mastered everything. Factorization method, formula method, completing the square, graphical. I knew everything. Like I didn't need to open my books anymore. Indices, logarithm. I covered topic after topic after topic after topic. Like I literally ate the entire textbooks. One of the things I did was I went to past questions. Like you find all the indices question in the entire past question, many years, like 20 years, 2020, 2000, 2001. You know how past questions look now. I solved everything, like literally all of it. You go on. One of my best topics then was circle theorem. Oh jeez. So you have theorem 1, theorem 2, theorem 3, jeez, that stuff is stressful but exciting. Anyways, that's not about that. So this is how you attend to a question under chain rule. So the first thing you do, equate this to u. So let u equals this. Then that automatically, if this is u, that now means y is u raised to power 5. State it out here. Then you differentiate individually. Differentiate this u with respect to x. Differentiate this. Then this is your formula, your chain rule formula. So once you can get this, substitute. What's dy du is this. Put it in. What's du dx is this. Put it in. So once you've multiplied and done all your stuff, bring back your value for you and put it inside here, and you're done. So that is how you attempt to the chain rule. Now quickly let's go to the next rule, which is product rule. So product rule number 2. I'll show you where you use something like product rule. That first one I told you is when you have a chain and then there's a big power and you cannot start multiplying using binomial expansion. That's stressful. So the best thing is to use chain rule. Now, let me find a question that has to do with product rule. Alright, so question, product rule. One second. Alright, so let's do this. I want to start. These textbooks, I don't understand them. They like stressful questions. Well, I want to start with something a little simple. 2x minus 1 x squared plus 5. Now, you would agree with me that this and this are multiplying each other. That's called product, right? So if they tell you what's the product of 3 and 5, that means multiply 3 by 5, basically. So this, the sign binding these two together is actually multiplication sign. So what we're doing here is product. So whenever you see something like this, they're telling you product, using product rule. Now if they say y is this, if y is this, find y dx. Now, here is a little more different because here we have two different stuff that will be equating. Now, the first thing you do is let u equals this, right? Then let v equals this. In quotient rule, you are dealing with u and v. In chain rule, it's just u. Now, then you now differentiate. Differentiate this u with respect to x. So you have du dx equals what? Differentiate this. That's 2. I'm sure you know that already. The power here is 1. 1 times 2 is 2. 1 minus 1 is 0. X equals by 0 is 1. It becomes 2. Now, here, this is a constant, so it's 0. Now here we have dv dx is what? 2x. Sorry, 2. 2x rather. 2 multiplied by this. Subtract 1 from this. You have 2x. Now the formula, once you get to this point, then we need the formula for product rule. And the formula is dy dx equals v du dx plus u dv dx. So the formula is v du dx, u dv dx. So this is the formula for solving using product rule. Now, what do? Substitute for v, substitute for du dx, substitute for u, substitute for dv dx. So let's do it. So what's v? X squared plus 5. What's du dx? 2. Plus, what's u? 2x minus 1. What's dv dx? 2x. Open the bracket. This times this, that's 2x squared plus 10. Plus, open the bracket here, that's 4x squared. Sorry, this is just 2x. 2 times 2x squared. That's 4x squared minus 2x. Now, you can add these two together. You have 6x squared minus 2x plus 10. Now, this is how you solve using product rule. This is how you solve using product rule. So, let me try to explain it. Just like you did in chain rule, let u equals this, let v equals this. So u is 2x minus 1, v is this. So what's the next thing? Differentiate each of them with respect to x. So du dx is 2. When you differentiate this, you get 2. dv dx is this. Then you need your formula. This is the formula for product rule. dy dx equals v du dx plus u dv dx. Alright, so v du dx plus u dv dx, that's the standard formula for product rule. So then you need to find your v, put it here. What's du dx, put it here. What's your u, put it here. What's your dv dx, put it here. Then just do normal expansion and so on, solving, and that's all. And you arrive at this. So this is your answer. This is how you attempt to the question under product rule. Now the last thing I'm going to be doing is going to be quotient rule. Let me see if I can find the question under quotient rule. Now quotient basically means division. So let me clean this now. Let me give you a minute to take it all down. Alright, very quickly, I want to attempt quotient rule very quickly. Alright, so I'm going to clean this now. So now quotient, what's the question again? I'd rather just use that same question. I'll just readjust it. So you had something like this. This is number 3 now, quotient rule. You had 2x minus 1 over x squared plus 5. Division. That means you need quotient rule. The other one was multiplication, so we need product rule. This one is division, so we need quotient rule. So what do? Same thing. They say if y equals this, find dy dx. Right? Now, let me show you many ways you can express dy dx. You can either say dy dx or f prime of y. This also works. Or what again? Or y prime. They mean the same thing, differentiation. When you begin to do something like this, y prime prime, that means you are differentiating twice. That's what I said at the beginning. You find the first derivative, the second order derivative. You can differentiate. Let me try to is it digress a little? Yeah. Imagine you had something like this. Y raised to power y equals let's do 4x raised to power 5. You now say find the first derivative, meaning find dy dx. Dy is the same thing as dy dx, right? Equals what? 5 times 4, that's 20 x raised to power 4, right? It's still the same. This dy dx, you still either you call it y prime or f prime of y, still the same thing. Now, this now, if you want to differentiate this thing second time, you want to differentiate, I don't know why I'm digressing, but let me just do it. It's called d squared y over dx squared, or y prime prime. Sorry, double prime rather. Or y prime prime prime. That's the third one. If you're having something like this, this now will be 80 x raised to power 3. If you're differentiating again, it will be what? 240 x raised to power 2. If you're differentiating again, it will be what? 480 x. If you're differentiating again, it will be 480. At this point, if you differentiate it again, it's a constant, it turns to 0. So I don't even know why deviated, but you get the gist, right? So that's what differentiation basically is. Now quotient rule. The first thing you do is let u equals this, let v equals this, as always. So let u equals this, 2x minus 1. And then let v equals x squared plus 5. Right? Right. Now, what is u? U is this. Now let's differentiate u with respect to x as always. What's du dx? Now this now begins to get a little engaging, because to me I believe this should be the first topic in mathematics. That's just my suggestion anyways. So du dx is this. So now let's differentiate this. What do you have? 2, right? 1 multiplied by this, 1 minus 1, 0, right? 2. Differentiate this. dv dx is what? 2x. This is a constant, it disappears. This is a constant, it disappears. Never forget that. Now what's the formula for quotient rule? dy dx is what? V, this one starts with v. V du dx minus u dv dx all over v. Is it v or v squared? Let me confirm that. So that's basically how you solve this kind of questions. Yeah, v squared. I just remember. Now, that's how you solve this. This is the formula. Now, this one is a little stressful because now we have to look for v. What's v? X squared plus 5. What's du dx? That's 2. Minus, what's u? 2x minus 1. Always use brackets. What's dv dx? 2x. What's v squared? This is v squared. All over what? X squared plus 5 all squared. It's going to start getting stressful. Now, open the bracket. 2x squared plus 10. I'm not going to explain this because I've done this already. You can go back to your other classes and check them out. Expand this. You have 4x squared minus 2x all over what? X squared plus 5 all squared. Now let's add. This can subtract this. That's minus 2x squared minus 2x squared. What again? Minus 2x plus 10. Minus 2x plus 10 over this x squared plus 5 all squared. This is the answer. There's no, you can't write it down further than that. So this is the answer to this. So once you can equate, find this, just substitute them and you have your answer. So that's basically how you do it. Let me try to go over it again. Let u equals this, let v equals this. For chain rule, it's just one that has a chain and the power. So it's just u, let u equals that. And then you solve using the chain rule. For product rule, there are two numbers. So let u equals the first one, let v equals the second one. Then differentiate each of them with respect to x. Then now put them in the formula and so on. For this one, let u equals the one at the top, let v equals one at the bottom, and then differentiate each of them individually. Then use the formula, then substitute, and you're done. So this is actually what calculus is all about. You're basically looking for the change in the state of an object with respect to something else. So yeah. So I think I'm going to end it here. Tomorrow we're going to be having more like a recap, and if there are places I've not touched, maybe you can make some comments in the comment section. I can attend to it tomorrow. So basically tomorrow will be a recap of everything else. I'm trying to see if I could actually do something like this again, or maybe not exactly 14 days stuff. Maybe it's just be, I'm still thinking about it, but whatever it is, I'm gonna let you know. Yeah, I'm gonna let you know. So I'll see you tomorrow. Have an amazing day.